My friends, we're trying something different. Whiteboard. I'm going to put the problem on the screen. I'm going to try using whiteboard to see how that goes. Let's see if it's less or more time consuming, or better or worse, or the lighting's better, the sound is better, the lighting's worse. I don't know. We'll see. So, a liquid mixture containing 60% ethanol and 5% weight of a dissolved solute. Alright? So, basically, we're going to be doing some kind of, separation process. So, as usual, I want you to pause the video and do this yourself. Okay, so read the problem, try it out. I'm going to start in 5, 4, 3, 2, 1. Okay, so, cool. Okay, I'm liking this so far. So, this is a distillation column. Okay, so I'm going to draw this. I'm going to separate our top and our bottom. So far this is faster. Okay, only thing is, gotta be careful how high up I go. I'll do this down here and to the right. Perfect. Perfect. Okay, I'm getting the hang of this already. So this is the distillate and the bottoms. So this is the distillate and the bottoms. We've done a bunch of distillation columns already. Okay, so the liquid mixture contains, what do we have? Okay, so we got some 0.6, right, kilograms of what? Ethanol per kilogram. Okay, this is going to be our feed stream. And then we're going to have the distillate. What else we got? And 5% dissolved solute. It's going to be 0.05 kilograms solute per kilogram. Alright, and then the balance, 0.05 of water per kilogram. Okay, so we have 3 components. Can you all see that? See, that's another thing I'm worried about. Is it readable? Because my penmanship is not the best. But I think you can see that. We got 0.6 kilograms ethanol, 0.05 kilograms of solute, and the balance is going to be water. So what are we going to do with this process? We're going to separate it. So there's going to be stuff on the top and stuff on the bottom. So notice how on the top it says that the it calls for the product stream to have equal mass flow rates. All right, so equal mass flow rates means we can write an equation that the bottoms is going to be equal to the distillate. Kind of cheating. And what else we got? And it says that the top stream 90 weight percent ethanol and no S. So this means 90 weight percent ethanol and no S, which means that's going to be 10% water. Great. Okay, so I hope y'all can read that. I'm testing things out with this video, but I hope you can read this. So we got the feed, distillate, the bottoms is equal to the distillate. Alright, if you haven't gone this far, I recommend you pause the video, try it out yourself. Okay, sumo basis calculation, do a degree of freedom of analysis. Well, we have some stuff coming down here, so I'm just going to write some variables such as the mass fraction of ethanol in the bottom stream, and this is going to be the mass fraction of what else we got? Solute in the bottom stream, and the mass fraction, mass fraction of water in the bottom stream. But really, if we know these two, then we automatically know this one. Careful with that ethanol stuff, y'all. Don't be drinking that the night before your exam, okay? Trust me, you don't want to do that. I speak from experience. No, I'm playing. Degree of freedoms. Okay, so I didn't really do the best job of explaining degrees of freedom because, to be completely honest with you, I don't like doing degrees of freedom. So degrees of freedom, you just take the number of equations minus the number of unknowns. All right. So what do we got? We got the unknowns. Well, the unknowns we're gonna have the feed. All right. All right. What else we got? We can look at the mass fractions right here. So these two. Mass fraction of ethanol on the bottom, and the mass fraction of ethanol of the solute in the bottom. You might be tempted to say, oh, water is also an unknown, and B is also known. But because we know that B is equal to D, that kind of eliminates that because you can write an equation for that. And and if you know these two, then remember the summation of all the mass fractions is going to be the overall whole. Okay, so that doesn't make sense, check out one of the previous videos. I'm referring to this equation. Okay, remember you're gonna have that equation. Okay, hope you guys can read that. All right, let me know how this is going. This is really, honestly, this is really me. Like, we're continuing the videos, but I'm testing this out. All right, and so what do we have for the the equations? Well, we got the what? The overall mass balance, and we got the what? The ethanol balance. All right, the ethanol balance, ethanol mass balance. Careful with that ethanol. And we got the solute mass balance. Great. Oh, looky here. 3 equations, 3 unknowns. So that means the degree of freedom is 0. Great. Part B. I'm liking this so far. I hope you all are liking this because this is more fun for me actually. You know what? It's all fun. It's just time. All right. I'm kind of busy. All right. So calculate the mass fraction of S in the bottom stream, the fraction of ethanol in the feed that leaves in the bottom product stream. E.g., i.e., kilograms in the bottom stream per kilogram in the feed, if the process operate is designed. Alright, so when in doubt, accumulation equals n minus out. Alright, I'm going to erase that because degrees of freedom are pointless. Excuse me. Not really, you should write it every time. So, accumulation equals n minus out, so we're going to do the feed is equal to the what? The distillate plus the bottoms. Alright, so these are equal to each other, so right, I'm going to write F equals 2D. 2D, not 3D. I need to stop with those lame jokes. Alright, so, well, we can assume, it says, assume, oh, did I miss something? See, that was my bad. See, that's what I was afraid of. We're going to make, oh no, I didn't. We're going to assume that since it's asking for a ratio, okay, right. This is the first time that I'm introducing making a basis of calculation. Oh, I noticed it's a little, seems a little lopsided or something. I don't know. So we're doing a basis of calculation. So for me, this was pretty confusing, but all it is just a ratio. So since it asks us to solve for the kilograms of E in the bottom stream with respect to the kilograms of E in the feed, that means we can make a ratio for the feed. So the best thing to do, or the most intuitive thing to do in my opinion, is just to set the feed ratio equal to 100 kilograms. Alright, so 100 kilograms is going to be the feed ratio. So basically, we have this unknown. So we have 100 equals 2D, and so therefore D is equal to 50, which is also equal to B. So we already finished the overall mass balance. Okay, so that's pretty good. Like, you can check that off, or you can even write it here if you want. And intuitively, it should make sense because 100 equals 50, so great. Alright, next, what else should we do? Well, what other kind of mass balances can we do? We can do the ethanol mass. Did you choose ethanol because you want... I don't want no alcoholics on my channel, alright? So, the ethanol mass balance is going to be right here. So this is equal to this plus this, alright? So remember, we're going to multiply them together. So we have 0.6, alright, times, so this is going to be the ethanol mass balance. Ethanol mass balance down here. Alright, 0.6 times 100, 0.6 times 100 is equal to, alright, 0.9 times the D, which we got 50. Alright, 0.9 times the distillate plus, well, the mass fraction of ethanol on the bottom, and times the distillate again, which is 50. Hey, look, we can solve for that. All right, it's gonna be your job to solve for it. Bum, 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 bum. So what I got was approximately 0.3. Great. All right. So this is the mass fraction down here. Like I said, I like to put it down here. All right. Are we done? No, we have to answer the question. So, by the way, please review the other videos if you don't recall exactly why you multiply these, okay? Very, very important that you understand intuitively why you're multiplying these, okay? Don't just memorize, understand. All right? So, now we can do, what else do we need? Well, we're going to need some stuff down here, right? Because we need the kilograms of the ethanol on the bottom, right? So, actually, yeah. Kilograms of ethanol on the bottom. So what we can do is solve for the ethanol in the bottom stream. So I'm just going to call it the ethanol and the mass of the ethanol in the bottom stream. It's going to be what? Just multiply that. It's going to be the mass fraction of ethanol in the bottom stream, which is right here. So check that. Times the bottom stream itself. We have that. Check that. So it's going to be 0.3 times 50. Alright. Calculate that. And similarly, we're going to have the mass of the ethanol in the feed. Alright. So it's going to be this guy. 0.6 times 100. Alright. So now I want you to, what? It asks us to calculate the kilograms, the mass of ethanol in the bottom stream with respect to the mass of ethanol in the feed stream. Right? So that's what we're going to calculate. So I want you to calculate this ratio. Alright? Do it yourself, please. What do you get? Do you get about 25%? You get 25%? That is the answer for part B. Alright? I'm not going to do too much algebra from here on out because I want y'all to do it yourself. Alright? If I made a mistake, hopefully I'll catch it before I post the video, but I think it should be decent. Okay, so that's part B. Does that make sense? Hope it makes sense. Alright, great. Part C. Yeah, see, this is pretty fun too, because doing the whiteboard stuff, I'm more like interactive. It's kind of what I'm doing. Alright, so part C. So, let's read this together. An analyzer is available to determine the composition of ethanol water mixtures. So the calibration curve for the analyzer is a straight line on a plot on a logarithmic axis of mass fraction of ethanol, x. I like to use W because when you take mass transfer and separations, you have x, y, and W and z, so I'm going to use W from here on out. Versus analyzer reading R. So, x versus R. Interesting. So, the line passes through the points R equals 15, blah, blah, blah. Derive an expression for x as a function of R based on the calibration, and use it to determine the value of R that should be obtained if the top product stream for the distillation column is analyzed. Alright, so let me kind of explain. As a little precursor, you know, this concept of logarithmic and semi-logarithmic axis was pretty confusing to me until I took Matlab course. So what I'm gonna do is give you like kind of like a cheat sheet. Alright, so please box this, write this down. So for logarithmic axis, you're gonna use this equation. Y equals ax to the b. Alright? And for semi-log, you're gonna use y equals a e to the bx. So please box that. Alright? So what does that mean? So notice how for the log scale, alright, for this guy, for the log scale, we're going to use the power law. Power law, okay, right? Because it's x to the b, so that's a power law function. And then for this guy, we're going to use an exponential equation. Alright? So what does that mean? So quick recap of, you know, just a Cartesian plane, right? If it's just linear, this is going to be linear, okay? So this is just going to go generally 1, 2, 3, 4, etc., etc. Okay? On a log scale, this is going to be 0.1 to 1, right? You're going to keep multiplying by 10. 0.1, 1, 10, 100, etc., etc. And whatever values these are, this is actually really going to be, right, 10 to the negative 1, 10 to the 0, 10 to the 1. So this is going to be a log scale on the x-axis, okay? If it's semi-log, then one of the axes, let's say in this case the x-axis, will be a log scale, and the other will be linear. Okay? So this is going to be semi-log because one of the axes is log, namely the x-axis, and the y-axis is going to be linear. However, so this is semi-log. So if both of the axes are in the log scale, such as 0.1110 on the x-axis and 0.1110 on the y-axis, then this is going to be a log plot. Okay, so in this case, it asks us to do logarithmic, right? It says logarithmic axes. Okay, so we're gonna choose kind of something like this plot. So I want you to check this out. Okay, do you box this? So check this out. So we have y equals ax to the b. We can do some pretty fun algebra, right? So, okay, we're gonna take the natural log of both sides. See what I'm getting at? I want you to pause here, think about this. Okay, can you read that? You should be able to read that, right? So the natural log of y. Okay, well, what can we do here? I want you to play around with the algebra, see if you can get a pretty fun expression. I'll leave the natural log of y right there. And because of these rules, you can separate it like this, right? X to the b. So now we're just adding them together. But remember how you can pull down this b over here. ln of a plus b ln of x. Does that look a little familiar? Hope it does. Doesn't it kind of look like y equals mx plus b, right? So this is, now we converted the log plot from the power law into a linear form. Great. I kind of got this when I was taking this class, but it didn't really click until I took Matlab / numerical methods class. My phone is about to die, so we'll see how this works. What else we got? So now, alright, so now we can use this equation. But notice how your y turns into ln of y, your b turns into ln of a, which is right here, your m is your b, and your x is your ln of x. I know this is all confusing, but I don't want you to think in terms of y equals a function of x. I want you to think as output. Output is a function of your input. Namely, where your output is ln of y, and your input is ln of x, where you have a slope b and a y-intercept a. Got it? Got it. Great. So now all we have to do is solve for these parameters. Well, gee willikers, how can we do that, Mr. Sanchinieri? Well, don't worry, I got y'all. Alright, so we have some points. Okay, we have 15, 0.1 and 38, 0.4. So this is our xy, right? Wrong. This is actually gonna be your r, x1 and r, x2. So now your slope, which is really your b, which is really gonna be y2 minus y1 over x2 minus x1, is now gonna be ln of x2, right? x2 minus ln of x1. Right, because this is now our new x. Excuse me. Yeah, this is our new y. Okay, so now this is our new y. This is why it's so confusing, because the x turns into y, but don't think about x in terms of y. Think of it in terms of the output as the input. So for the slope, it's the output difference minus the input difference, right? Delta y over delta x. This is your delta y now, okay? And this is going to be your R2 minus R1. ln of R2. Right? Yeah. Do you see what I'm saying? Because this is your new y, which is really x, x2, and this is your new x, which is really your r, okay? So it's delta y over delta x. If that was confusing, I'll just give you the numbers. So it's going to be ln of x2, you can plug that in, 4, minus ln of x1, which is going to be 0.1 all over, right? ln of R2, which is going to be your 38, minus ln of 15. Okay, you plug that in. Now your b for this equation, okay, so now your b, calculate that out. Your b is going to be 1.491. 1.491. Alright. So really we can write this, I don't know, I'm going to erase this now if that's alright. Yeah, we're running out of room, so I'm going to erase this. Okay, so now I'm going to replace that y equals ax plus b, y equals x to the b, which is now 1.491. Well, how can we solve for the other stuff? Oh, hey, look, I have 2 points I can plug in. So now I'm just going to plug in, I don't know, right? This is now really x as a function of r equals a r to the 1.491, right? You see what I'm doing? Because this is your rx. Now x is a function of r. I want you to think of the output as a function of the input. So now if x is a function of r, let's just take this point. Point 1 equals a, well, we don't know that. R is going to be 15 to the 1.491. If you solve this, you're going to say a equals 1.76 times 10 to the negative 3. Got it? Alright, that was my bad. My phone died. So I just kind of rewrote what I have here in PowerPoint, like the rest of chapter 4. Anyway, so what we solved for was a was 1.76 times 10 to the negative 3. So now we can plug it into our equation for x equals a r to the b. So this is our equation for x as a function of r. Now, using this, we can solve for what the r value should be attained of the top stream. We do have an x value, right? Because this is our x, which is really our w. Remember, I'm using w and x interchangeably in this class. So we can solve for r as a function of x by rearranging this equation mathematically, algebraically. Sorry, not sorry, I'm going to skip the algebra, but you can rearrange it yourself. We should obtain something like this. So now we have r as a function of x. Plugging in remember, x is the mass fraction, so we're going to plug that in here. For x equals 0.9, then r should be about 65.5, which is a clever little method that you can do to check your calibration in the lab or in an experiment or in industry if you have some kind of process just like this. All right, so in this video, I'm adding some tips because I want you all to kind of think about these things if you have some midterms coming up. Number 1, try to do the problem as much as you can by yourself, all right? Please understand that this is actually extremely important. If you're stuck, break it down and come back to it later and sleep on it. There's a lot of research on sleep that it's actually extremely vital. There are many ways to doing a problem. Try your own way. And careful how you confuse the variables because sometimes they can be pretty confusing. But really focus on understanding the problem and the problem solving because that's way more important than memorizing. And you can try different studying habits such as studying with friends or using a whiteboard versus pen and paper, and simulate the exam as much as possible. So find out what's allowed, such as a calculator or the textbook. Whatever is not allowed, then try not to use it while you're studying. Okay, so that's it for this video. Please let me know how this went using the whiteboard. I've tried a billion different methods on this channel so far. I've done like digital boards, and now I did the whiteboard, PowerPoint. What is your favorite? I really want to know. I'm trying to pick out my favorite too, because they all have their strengths and weaknesses. Okay, thanks for watching. Have a good day. Bye-bye.